classification of elements and periodicity in properties. We are going to solve some multiple choice questions based on this topic. Question number 1. The electron gain enthalpy of bromine is 320 kilojoules per mole. Calculate energy released when 4 grams of bromine is converted to Br minus. Atomic mass of bromine is given as 80 grams per mole. So, the value given 320 kilojoules corresponds to 80 grams of bromine. So, what you need to do is find the number of moles of bromine and then multiply with the electron gain enthalpy, you get the value. So, the energy released is equal to 4 by 80 into 320. That comes to 16 kilojoules. So, the correct answer is 16 kilojoules. Well, this was question number 1. The correct answer we got is 16 kilojoules per mole. It's just a matter of finding out number of moles of bromine and multiplying with electron gain enthalpy. Well, question number 2. The first ionization enthalpy of lithium is 520 kilojoules per mole and electron gain enthalpy of chlorine is minus 350 kilojoules per mole. Calculate delta H for the reaction. Li gas plus Cl gas gives Li plus gas plus Cl minus gas. So, it is just a matter of adding the two thermochemical equations. Now, the thermochemical equation you write for the ionization enthalpy of lithium is Li gas gives rise to Li plus gas plus electron, and the energy change in this process is 520 kilojoules. This process is endothermic, so it is 520 kilojoules plus. Now, the next thermochemical equation is electron gain enthalpy of chlorine. Cl gas picks up the electron and gives rise to Cl minus gas, and the delta H for this process is given as minus 350 kilojoules. If you add these two thermochemical equations, the electrons get cancelled out. So, you get Li gas plus Cl gas gives rise to Li plus gas plus Cl minus gas, and the delta H for the overall process comes out to be 170 kilojoules. We need to take the algebraic sum of these two. These are extensive properties. Delta H is an extensive property. When you add the thermochemical equations, the values get added. So, that is the answer. So, the answer is 170 kilojoules. Question number 3. An element X has atomic number 34. Its position in the periodic table is. So, what is the atomic number? It is 34, and we are asked to find out the position of this element in the periodic table. See, our reference element is the nearest inert gas. The reference element is krypton. Krypton is a member of 0 group. So, its atomic number krypton is 36, right. So, krypton is a member of 0 group. This is 2 units short of krypton. So, it has to be see, just before krypton is 7A group, and before that you have 6th group. So, this element belongs to 6th group. And remember, helium is the member of first period, neon is the member of second period, argon is third period, krypton is fourth period. So, krypton is fourth period 0 group. So, our element, this has to be fourth period only, but it should be 6th A group because its atomic number is 2 units less than that of krypton. So, the correct answer should be 4th period group 16. So, the correct answer is third option. Group 6 means as per latest convention it is taken as group 16. This is older convention, IUPAC convention, it is taken as 16. So, the correct answer is third option. Question number 4. Which of the following has more negative electron gain enthalpy? The options are number 1 oxygen, number 2 fluorine, number 3 sulfur and number 4 chlorine. And we know that the element chlorine has highest electron gain enthalpy. It is not fluorine, it is expected to be fluorine, but it is not fluorine, since fluorine has extremely small size and the incoming electron experiences greater repulsion. Therefore, electron gain enthalpy of fluorine is less than that of chlorine. So, the correct answer is fourth option, chlorine. Chlorine has highest electron gain enthalpy, fluorine has highest electronegativity. Question number 5. Which one of the following is correct relation of screening effect and ionization enthalpy? Relationship between screening effect and ionization enthalpy. Look at the options. Number 1, as screening effect increases, ionization enthalpy also increases. Number 2, screening effect is not related to ionization enthalpy. Number 3, as screening effect increases, ionization enthalpy decreases. Number 4, as screening effect increases, ionization enthalpy increases up to a limiting value and then decreases. See, what is screening effect? Imagine this is a valence electron and here we have intervening shells. These act as screens and they decrease the nuclear charge on the valence electron. So, as the number of screening electrons increase, the attraction of nucleus on this electron will be decreased and this electron can be lost easily. So, we can say as the screening effect increases, ionization enthalpy decreases because screens decrease the nuclear pull on the electron. So, the correct answer has to be third option. As screening effect increases, ionization enthalpy decreases. Question number 6. The radii of Fe, Fe2 plus, Fe3 plus follows the order. Remember, as the magnitude of positive charge increases, size decreases, because when more and more electrons are removed from an atom, the effective nuclear charge increases and the nuclear attraction will be increased on the valence electrons and therefore size shrinks. So, the correct answer is ferric will be smaller than ferrous, ferrous is smaller than Fe. So, the correct answer is fourth option, Fe larger than Fe2 plus, this is larger than Fe3 plus. Fourth option is the correct answer. As the positive charge increases, size decreases, and as the negative charge increases, size increases. Question number 7. Na plus and neon, sodium ion and neon both are isoelectronic with 2s2 2p6 outer electronic configuration. Their ionization enthalpy values are related as. See, ionization enthalpy is the energy change involved in the removal of electron from a atom or ion. It is easy to remove electron from neon when compared to removing from sodium, because sodium is already carrying positive charge. When compared to neon, effective nuclear charge of Na plus will be high. So, you can say, look at the options. First option says ionization enthalpy of Na plus and ionization enthalpy of Ne are same. This is not true. Then you have ionization enthalpy of Na plus is greater than ionization enthalpy of neon. This is true because Na plus has greater effective nuclear charge. So, on similar lines you can rule out third possibility where we say that ionization enthalpy of Na plus is less than that of neon. This is not true. Na plus has more ionization enthalpy than Ne because of greater effective nuclear charge of Na plus. Correct answer is second option. Question number 8. Increasing order of ionic radius among Al3 plus, Mg2 plus, O2 minus, F minus. You have to arrange these species in the increasing order of their ionic radius. As I told you just now, as the positive charge increases, size decreases. These are all isoelectronic species. They all have same number of electrons in their atoms. So, they are called as isoelectronic species, As the positive charge increases, size decreases, or I can put it like this: as the negative charge increases, size increases. So the correct order of sizes: Al3 plus will be the smallest among them, then comes Mg2 plus, then comes Na plus, then comes, they are all isoelectronic, then comes, we don't have Na plus there, so we can take it as F minus and O2 minus. The largest is O2 minus. Therefore, from the options you can say the correct answer is third option. Question number 9. To which period and group the element with outer electronic configuration NS2 NP3 belongs when n is 3? See, when we say n is 3, it is obvious that it belongs to third period. And when it comes to group number, we need to simply add the number of valence electrons. When we say NS2 NP3, number of valence electrons are 5. Therefore, it belongs to 5A group or 15th group, and the period number is third. So the correct answer is fourth option, 15th group and third period. Question number 10. The two isotopes of an element have the same, option 1, same ionization enthalpy, option 2, different ionization enthalpies, option 3, heavier isotope has more ionization enthalpy than lighter isotope, option 4 is lighter isotope has more ionization enthalpy than heavier isotope. Isotopes have same size, isotopes have same ionization enthalpy. So the correct answer is first option, they have same ionization enthalpy. Question number 11. The pair of elements with highest electronegativity and highest electron gain enthalpy respectively is: first option fluorine chlorine, second option fluorine oxygen, third option chlorine oxygen, and fourth option is fluorine nitrogen. Actually, the correct answer is first option. Fluorine is the element which has highest electronegativity among all the elements in the periodic table, and it is the chlorine which has highest electron gain enthalpy, which is also called as electron affinity. So the correct answer is first option, fluorine with highest electronegativity, and second chlorine is the highest electron gain enthalpy. Which of the following oxides form strong base when dissolved in water? See, remember, Al2O3 being an amphoteric oxide is insoluble in water. Na2O dissolves in water and produces NaOH. This is a strong base. Then you have P4O10. P4O10 dissolves in water and produces acid H3PO4. Then you have SO3. SO3 dissolves in water to produce a very strong acid, sulfuric acid. So while the Al2O3 is insoluble, these two produce acids. So the correct answer definitely is Na2O. Second option is the right answer. Na2O, when dissolved in water, produces strong base sodium hydroxide. Question number 13. Which of the following oxides form strong oxyacid? Which of them form strong oxyacid? It's the same options, and we know that Al2O3 is insoluble, Na2O produces base sodium hydroxide, P4O10 produces weak acid H3PO4, and the substance which produces strong acid is SO3. SO3 produces strong acid, sulfuric acid. So the correct answer is SO3, fourth option. Question number 14. The element with largest atomic radius among the following is: options given are aluminium, potassium, chlorine, and calcium. We know across a period size decreases from left to right. At the extreme left you have the largest atom, and on the extreme right you have the smallest one. Extreme right means halogens. In noble gases the case is different because we consider van der Waals radius. So the atom which is expected to have largest size is potassium, the alkali metal, and the atom which is expected to have smallest size is chlorine, that is halogen. So this is the order of size of these atoms. So the correct answer is second option, potassium has the largest size. Question number 15. The oxidation state and covalency of boron in BF4 minus. In BF4 minus, boron is surrounded by 4 fluorine atoms. So there are 4 bonds surrounding boron, therefore covalency can be taken as 4. Whereas for the sake of calculation of oxidation state, let us assume that boron is X plus 4 into minus 1, it comes to minus 1 because the sum should be equal to the charge carried by the radical. So X will come to plus 3. So oxidation state of boron is plus 3, its covalency is 4. So the correct answer is fourth option. Covalency corresponds to number of covalent bonds formed by an atom of element. Question number 16. The element with highest oxidizing ability is. The element with highest oxidizing ability. See, oxidation means loss of electron and reduction means gain of electron. So for an element to have highest oxidizing ability, it should have an ability to accept electron and oxidize another substance. So the element which has highest ability to accept electron among them is fluorine. Look at the options. Cesium has a tendency to lose electron, it acts as a good reducing agent. Fluorine is highly electronegative, so it's a good oxidizing agent. Lithium again is a reducing agent because it's an alkali metal, tends to lose electron. Oxygen is also an oxidizing agent, but between fluorine and oxygen, fluorine is more powerful because of its higher electronegativity. So the correct answer is 2. The reaction which is responsible for this is F plus electron gives F minus. The tendency for fluorine to pick up electron and become F minus is very high. So this is the reaction which is responsible for oxidizing nature of fluorine. It itself gets reduced to fluoride. Question number 17. 3 elements A, B, C are placed at extreme left, middle and extreme right of the periodic table respectively. That means A is in the extreme left and C is in the extreme right. The most acidic oxide is formed by which element? See, across a period in a periodic table, as you move from left to right, basic nature of oxide decreases and acidic nature increases. So at the extreme left you have strongly basic oxide and on the extreme right you have strongly acidic oxide. For example, in the extreme left you will have K2O, which will give potassium hydroxide when dissolved in water. So this is a basic oxide. On the extreme right you have Cl2O7, which will dissolve in water to give perchloric acid, which is a very strong acid. So the correct answer for this question is option 3, that is C. C, which is on the extreme right, will form most acidic oxide. Question number 18. The plot of ionization enthalpy and atomic number, the maxima and minima respectively represent. See, ionization enthalpy. The element with highest ionization enthalpy in a period will be noble gas, and the element with the lowest ionization enthalpy in a period will be alkali metal. So the minima will be alkali metal and the maxima will be a noble gas. So the correct answer should be option 3. Noble gas is the maxima and alkali metal is the minima of the graph. So the correct answer is third option. Question number 19. Which of the following is not a consequence of lanthanide contraction? Which of these is not a consequence of lanthanide contraction? I'll read out the options. Difficult to separate lanthanides from their mixture. This is a consequence of lanthanide contraction. It is very difficult to separate lanthanides from their mixtures because of similarities in their properties. The covalent nature of lanthanide hydroxides increase and basic strength decreases. Most lanthanides exhibit +3 oxidation state. Fourth option is pairs of elements like zirconium hafnium, molybdenum tungsten, niobium tantalum possess almost the same properties. So the correct answer is third option. Their ability to exhibit +3 oxidation state has nothing to do with lanthanide contraction. So the correct answer is third option. Question number 20. Which of the following is a neutral oxide? Remember, oxides of metals are generally basic, oxides of non-metals are acidic, lower oxides of non-metals are neutral, higher oxides are acidic. So, lowest oxide among them is NO. Na2O, the first option, is basic oxide, SO2 is an acidic oxide, NO2 is also an acidic oxide, whereas NO is a neutral oxide. Look at the equations. When you dissolve Na2O in water, it will produce NaOH, as you know it. Second option, if you dissolve SO2 in water, you will get H2SO3, sulfurous acid. If you dissolve NO2 in water, you get a 1:1 mixture of HNO2 and HNO3. That means it is a mixed anhydride of nitrous acid and nitric acid, whereas NO does not dissolve. It is almost insoluble in water. The solubility is very low. It is a neutral oxide. So, the correct answer is fourth option, NO.